on the left. So we will do that. But today, mostly, I just want you to go over, balancing equations. Let's see. Then there was double replacement. That's double replacement. Everything is, they all switch places. Decomposition would be something like this. And then combustion is anything plus oxygen in the presence of heat will make something with oxygen. I should put oxygen compound, but I'm going to be lazy and put oxygen thing. But just so you know that oxygen thing's that's not a science term, obviously. So, all right, so this one is, I'm going to put them in a different color so you can kind of see. Okay, single replacement. This is an R. This is double replacement. Decomposition. Is it decomposition? Yeah, I think. S-I-T-I-O-N. I forgot how to spell it. And then the last one is combustion. Now, a lot of times with combustion reactions, you're not going to see the word heat there, but it should be in the presence of heat, and that's what causes it to, combust. Combust is like to burn in the presence of oxygen. All right, so let's also mention the reactants and products. So in a factory, do you start with a product or do you end with a product? So you're going along, right, you end with a product. It's the same thing in chemistry. So the products are at the other side of the arrow, right? And so the things that react are called basically reacting things, but it's called reactant. Or reactants, if you have more than one. All right. So reactants on the left of the arrow, products on the right of the arrow. What else? It's just kind of basic things. Let's see. I'm trying to find, I've got two screens set up, and it's kind of set up backwards from what I would normally do. So I keep looking for my cursor. Where'd the cursor go? I don't know. It's gone. Okay. Come on, do what I'm saying. Okay. So now, let's say we have a 2B and its decomposition. It would make something like B plus 2A. This is a coefficient. This is a subscript. The subscript tells me how many moles of A I have, or how many atoms of A I have in that compound. The coefficient tells me how many moles of the compound, or how many moles of, in this case, how many moles of A. For example, let's do something easy. We've got magnesium plus oxygen makes magnesium oxide. There are some side reactions in there, but we're not going to worry about that right now. So I see that there are two oxygens. I put a 2 here. One thing to note, never change the subscripts. All right, you can only change the coefficients. So now this 2, I'm going to take the 2 and multiply by the 2 coefficients. In this case, not coefficients, 2 subscripts. The subscripts here are implied to be 1. So 2 times 1 is 2 magnesium. 2 times 1 is 2 oxygen. So we're good on the oxygen, but we need 2 magnesium there. So those are the coefficients and the subscripts and the big difference between the two. All right, let's see. All right, so there are some symbols that you'll see in reactions a lot of times. Let's see. If O has the 2, why put the 2 in front of magnesium and oxygen? That's a good question. Okay, so you have magnesium plus oxygen gas making solid magnesium oxide. So if I balance them like this, there are two elements, so I'm going to write down the elements there. Right. On the left, I have, to begin with, I have 1 magnesium and 2 oxygen. And on the right, I have 1 magnesium and 1 oxygen. So I need more. Now I can't make it MgO2 because magnesium is 2 plus, oxygen is 2 minus, and that would give me a charge if I put the subscript. So, and it would change it into something totally different. So you can't do that. Like the difference between carbon monoxide, which is poisonous, and carbon dioxide, which we breathe in and out all the time. Obviously, you know, we keep the oxygen that we're breathing in, but it's all that. So the only thing we can change is the 2 to say, okay, well, if we have 2 oxygen on the left, well, if I say we have 2 magnesium oxide, then now my oxygens will match. So what I'll do at that point is I'll go back and I count again, and I have 1 magnesium on this side and 2 oxygen. And on the right, I now have 2 magnesium and 2 oxygen. So the oxygen is balanced, but now the magnesium is not. So then we're going to put a 2 here. And by doing that, we'll have 2 magnesium, 2 oxygen, and over here 2 magnesium and 2 oxygen. And now that they both match, it's balanced. The thing is that what we're doing is not necessarily adding magnesium to our equation or subtracting it. What we're doing is trying to find out what's actually happening. And to figure out what's actually happening, you have to balance it to figure out how many of these go with how many of those. This one is combustion, actually, and you can tell because of the oxygen. Or you could consider it a combination because, or it would be both, but the magnesium is combining with oxygen to make magnesium oxide. If it went the other direction, if it was magnesium oxide falling apart into magnesium and oxygen, that would be decomposition. All right, and here are the symbols that you'll see. Sure. Give me 1 second, I'll define the coefficients and the subscripts. So you'll see these symbols, and they're pretty intuitive. This is an L, by the way. My handwriting's not always the best. All right, the first one is gas. Second one is solid. This one is liquid. And this one is aqueous. Aqueous means dissolved in water. Some ionic compound, well, just something. You can kind of remember that because it's got this piece right here that's almost aqua, which means water. All right. Anybody need a second on this page before I go to the next one? No. Okay. Oh, yes. Okay. Just let me know when you're done, Chad. So I can define subscripts down here at the bottom and coefficients. All right. Oh, why am I writing that? The subscripts. The subscripts are going to tell the pieces of a compound. Thanks, Chad. So let's say we had A2B. The compound is A2B, and it's telling me that for A, I have 2 pieces, and B, I have 1 piece. All right, and I'll do coefficients on the next page. So that's subscripts. All right, coefficients, it's just like in algebra when you have like x and you have a 2 here. It tells me how many x's I have. So it'll tell how many of that compound. Let's see. Correct. Caspian's got it. All right. So let's do some examples. It'll be a little more clear as we go through the examples too. One last thing before we get into the examples, that if you have a hydrocarbon, and it's a combustion of a hydrocarbon, then you're going to end up with, in the very end, carbon dioxide plus water, assuming everything goes to complete combustion. In reality, you get side products, and that's why they have you do emissions testing and have all these things on your car to keep you from putting out so much carbon dioxide and things like, carbon monoxide and things like that. So, but the main thing here is hydrocarbon, which would be anything like CH4, CH2, any of those CH things, in the presence of oxygen, will produce carbon dioxide and water. So that you'll need to know for sure. All right, and the next thing that we're going to do is we are going to do an example. All right. So let's say we have methane, and it's a gas, and we have oxygen, and it's a gas, and then if that's all we're given in a question, then we're supposed to say, well, I don't need anybody to tell me what it forms because I know what it forms. It forms carbon dioxide and water. Carbon dioxide is a gas. And it depends, most of the time in the combustion reactions, water will be in the form of a gas because combustion is really hot, so it vaporizes it, so it's still a gas. It'll eventually condense, but immediately it does this. When you balance a combustion reaction, there is a process that is the most efficient way to do it. And that's to start by balancing the carbon, then the hydrogen, then the oxygen. No, it doesn't matter whether it's a gas or a solid. That won't change how you balance it, but that's a good question. So first thing that we're going to do, the only way that I can really describe it or explain it, and it's not a good explanation, when you do it in this order, it balances quicker. Part of the reason is because of this O2 here. Sometimes you'll end up with like an odd number on one side, and then you have O2 right here. And then, so that causes the oxygen to balance funny. So if you started with the oxygen, you could end up in an endless loop of oxygen balancing. And then hydrogen is also kind of hard, but carbon is just the easiest to do that. Yeah, so far carbon is the same. So the process to balance them, and you'll see me pretty much always do them like this. Once you get more used to it, you don't have to make a chart or anything. But when you're learning, and if you get to one that's kind of confusing, the chart is, I like the chart personally. Okay, so we have 1 carbon, 4 hydrogen, 2 oxygen. On this side, we have 1 carbon, 2, 3 oxygen, and then 2 hydrogen. All right. So the carbon is balanced because on the left I have 1, and on the right I have 1. But you can see the 4 and the 2 for the hydrogen, that's not balanced. And then the 2 and the 3 for the oxygen, that's not balanced. So the first thing I'm going to balance is the hydrogen. So I'm going to put a 2 right here, and that's going to cause there to be 4 hydrogen. And that's because I'm taking the coefficient here and multiplying it by the subscript. And that's going to cause there to be 4 hydrogen. I'm getting numbers 3 and 2 for hydrogen and oxygen. Oh, okay. For hydrogen, it was H2, so that caused it to be 2. And for oxygen, I'm just counting up how many atoms there are. So if you look on the left, you see there's a subscript here that's a 2. So that's O2. So there are 2 of them there. But then on this side, before I put the subscript, before I put the coefficient, like if there was no coefficient here, then you would just have H2O. And so that would be 2 hydrogen and 1 oxygen. So that 1 oxygen plus the 2 in the carbon dioxide would make the 3 oxygen. So now I'm going to rebalance now that I put the 2 there. So that's 1 carbon still, 4 hydrogen now, so that's in the right direction. And then we still we have 2 oxygen on the left, and now we have 2 times the 1 oxygen here, and that's just 2. So there's these 2, and these 2 is a total of 4. You're welcome. All right, and then so now the only thing left to balance at this point is the oxygen. So because we have 2 here and 4 here. So you can draw a line through those because those aren't too much matter anymore once you balance them again. Exactly. So we're going to put a coefficient of a 2 in front of the oxygen, and now we have 4 oxygen. If I look at this side again, I have 1, 4, and 4. And so balanced and balanced. Okay. Yes, you want to balance both sides. The reason is because of the law of conservation of matter. And so the law of conservation of matter says that you're not going to create or destroy matter in a chemical reaction. So let's say I have well, we could just look at this, and if I didn't balance it, it'd be CH4 plus O2 makes H2O plus CO2. So if we did that, then I'm saying on the left, I start with 1 carbon, I end with 1 carbon. Good. This one, I start with 4 carbon, I've destroyed 2 not carbon. I have 4 hydrogen, I destroyed 2 hydrogen here. They went into oblivion. See, that won't happen. And then here I have 2 oxygen, and now I have 3 oxygen. So maybe I converted the oxygen from the hydrogen that disappeared, but see, that doesn't actually happen. So this is due to the law of conservation of matter. And so that's why we have to balance it. Yeah, so in hydrocarbons, you start with the carbon, then you do the hydrogen, then the oxygen. If it's not that, then sometimes you have to just kind of guess where to start. Normally, if it's not a hydrocarbon, I just start on the left and work toward the right. But yeah, sometimes you have to try different numbers. Occasionally, they'll be horribly frustrating. And it's not necessarily that they're really hard. It's just occasionally you get stuck in the pattern of thinking about it one way. And as long as you sit there and stare at it, you end up, it won't balance no matter what you do. So if that happens, just take a break from it and come back later. And most of the time, it'll just balance when you come back and try it again. Well, there'd be longer elements that could be tricky that we would have to balance on the exam. Well, maybe longer than this, because this is our introductory thing. But they're not going to be, I'm not going to do like C16H12 of 6 NaXeY or something like that. So they'll be pretty similar to the examples I've given and to the ones that you'll see on your homework as well. You're welcome. All right, so let's do another one. I'm going to let you try this one this time. Or no, this one is, I will do this one with you. This one is a good example of one that's not hydrocarbon. Okay, so for this one, let's do gray this time. Okay, so I have cobalt oxide, and then I have carbon, and that's going to make cobalt and carbon dioxide. Sometimes you don't really know what it makes. Other times it may be something that's obvious that it makes that. For example, we'll go over some gas equations. The gas equations kind of always make the same thing, like hydrocarbons always make the same thing. In this case, you wouldn't necessarily know that it makes this at this point. I mean, eventually you could figure it out as you go through chemistry, but when you first start, it's not always clear. All right, so we're going to look at these and try to balance them. So I'm going to keep oxygen last because oxygen can be tricky. Just for the heck of it, I'll start with carbon, but I could start with cobalt just as easily. So I'm in this part, you're just kind of guessing which way you want to balance them. If in the end you end up with coefficients that all can be divided by something, like let's say you have a 6, a 3, an 18, and 9, then you know that you've gone a little too far, so you would just divide all of these. They're all divisible by 3, so you divide them all by 3, and then you get the correct ones. Yes, you should put the symbols here. You wouldn't necessarily know this. This would have to be given to you. Things like O2, that's definitely gas. You should do that, but actually this was a solid. I don't know why I put it as a gas. And then cobalt is a solid. It's a metal. I think it's a metal. And then this is a gas as well. Yes, solid oxygen does exist. You just have to get it really, really cold. How did I find out that the compound made cobalt and carbon? So in this case, this would kind of have to be given to you. I wouldn't just know off the top of my head that it makes cobalt and carbon dioxide, because it could maybe make a couple of different oxygen compounds. It could have made cobalt, carbon monoxide, and oxygen gas, or something like that. There's a bunch of different things that you could do. Let's see. Yes, we will multiply chemical equations on occasion. Those are usually the hydrocarbons, and actually that's my next example, is one where we're going to have to multiply it. All right, so for this one, how many cobalt do I have on the left? 2. And how many carbon? 1. And how many oxygen? 3. All right. Now looking on the right, how many carbon do I have on the right? 1. How many cobalt? Again, 1. And how many gas? How many oxygen? 2. All right. So looking at this, we can start pretty much anywhere. This one, the oxygen's not going to be as hard to balance because there's no O2 anywhere, like a single oxygen itself. By O2, I mean like this. There's not one of those. And sometimes that throws things off. So where do you want to, okay, carbon's already balanced. So cobalt would be pretty easy to balance. So how would we balance the cobalt? Okay. So far we would think that we'll start at 2 cobalt, and then that would cause there to be 2 of these, and everything else would be the same. And then looking at the oxygen, on the left we have 3, on the right we have 2. There's no way to just add 1 oxygen. You have to add them in pairs. Yeah, the cobalt's going to end up being a 4. But I'll show you that in a second. So looking at the oxygen, if I have 3 on the left and 2 on the right, what's a way that I could get it to balance? Any ideas? Yes, actually, yes. Correct. All right. So what we're going to do, the 3 here and the 2 here, we're going to look for the lowest common multiple. So I can go 3, 6. They can both be, 6 is divisible by both of them, right? So I'm going to try to make 6 on both sides. So on this side, I have a 3. What do I multiply 3 by in order to get 6? 2, correct. And on the right-hand side, what do I multiply 2 by in order to get 6? 3. All right, so I'm going to recount both sides. And before we go much further, I see here I've got 4 cobalt on this side, but only 2 on this side. So how would I fix that? I just, change this to a 4. All right, so let's see if it balances. Actually, it doesn't. Does anybody see what's not balancing? Yes, the carbon, correct. Because I have 3 carbon here and 3 there. So looking at it again, just to make sure it balances, I have 3 carbon, 4 cobalt, 6 oxygen. On this side, I have 4 cobalt, 3 carbon, and 6 oxygen. So now they balance. All right. So let's look at one that's more difficult that you'll likely run into from time to time. It's not too bad. Yeah, sometimes, I don't know, sometimes balancing, for me, I can enjoy balancing chemical equations. Sometimes it's kind of like a puzzle when everything falls together correctly. But then when you run across one that for whatever reason is just like I added a 3, now on the other side I put a 2. Now on this side I added 4, now on this side is 7. Before long, it just keeps getting bigger and bigger, and those drive me nuts. All right, let's take a look at one that has an odd number of oxygen at the end. That's a carbon, that's a hydrocarbon combustion. And I'll show you how to do those. CH4 or C4H10 gas plus oxygen gas, so it's combustion, makes carbon dioxide and water, gas. Okay, so now let's count everything on both sides. So we've got a carbon, hydrogen, and an oxygen. And you want to balance them in that order: carbon, hydrogen, oxygen.
Okay.
All right. So on the left, how many carbon do I start with? 4. And how many hydrogen? 10. And how many oxygen? 2. And on the right, how many carbon? 1. And oxygen? Almost 3, right? This one's, it's easy to forget this oxygen over here. So we've got these 2 and then the one in the oxygen, the one in the water. So that makes 3 oxygen. And then we have 2 hydrogen. All right, so we're unbalanced in everything. So we're going to start balancing with the carbon. So what am I going to put in front of the CO2 on the right? A 4. Good. All right, so now I'm going to balance again. Not balance, I'm going to count them again. So I've got 4 carbon. I've got 8 oxygen, because this is 4 times this coefficient of 2. And then I still have 2 hydrogen. So the carbon is balanced. That's nice. So now we're going to take a look at the hydrogen. On the left, I have 10. On the right, I have 2. So what am I going to add this time in front of the hydrogen? Correct, 5. Incorrect. You're correct, Holly. So that's going to be still 4 carbon. Yeah, that would be 9, because I forgot to add this one over here. Holly's correct. I told you it was easy to forget that guy over there. Okay, so you've got 4 carbon, and then 10 hydrogen, and then you've got 8 oxygen over here, and 5 oxygen over there, and so that would be 13. I'll draw kind of a line between those two. All right. So there's nothing you can multiply that's a whole number by 2 in order to get 13. Correct? That looks bizarre. It's like, okay, now what? So I will show you what. This one doesn't turn out to be, yeah, it does seem like it's pretty gross, doesn't it? It's not as hard as it sounds. So if I have 13 over 2, and I multiply it by 2, that equals 13, right? So in this case, we're going to temporarily use a fraction. So I'm going to do 13 over 2. Right? And so that's going to cause 13 over 2 to be 13, and this is still 10, and this is still 4. So now they balance nicely, but you can't have a fraction, right? Exactly. So Braylon is correct. You're just going to multiply all of these coefficients now by 2 in order to get rid of that fraction. Because if I have 13 over 2 and I multiply it by 2, that would, or I will just do this as I go. I'm explaining it crazy. Okay, so we're going to multiply them all by 2 in order to get rid of the denominator here. All right. So I'm just going to write this out again at the bottom. C4H10 plus O2 makes CO2 plus H2O. All right, and I'm going to multiply all of the coefficients by 2. I know to multiply by 2 because that's what my fraction was. I know that 2 is going to be on the bottom of my fraction because 2 is right here. All right, so initially I had no coefficient here, so that means a 1. 1 times 2 is 2. Get better color. Nah, just do red. Okay, so it's going to be 2. Now in front of the oxygen on the left, I have 13 over 2. 13 over 2 times 2 is 13. Okay? Now, 4 times 2 is what?
8.
Right? 8. And then 5 times 2 is 10. All right, and at this point, we're done. So take a second to look at it. Chad, what's your question?
Okay, so I noticed for the first row you got 13 when it had 2 at first. So I was wondering, how'd you get 13?
That's a good question. So on the right-hand side, I had that we have 13 oxygen on the right. So I needed to make 13 oxygen on the left. And so I'm going to have to multiply something by 2 because that's the subscript there. Something by 2 equals 13. The only thing that would be 13 over 2. Even if I didn't know and I just made it an algebra problem, then I come up with 13 over 2. Also, you're always going to have an O2 on that side. So all you have to do to make the fraction when you have this kind of problem is put the number you're trying to get over 2. Okay, Jack, what else do you have? Do you have another question, Chad? You're good. Okay. Any questions on this before I move to the next one? Nope. Okay. All right. Now let me give you guys one to give it a try. I'll give you a couple minutes to work on it, see what you come up with. So we've got this. You know what? Hang on a second. I need to start writing more to the left. Running out of space. All right, so that's what you're going to be balancing. Just one hint is that if I see a polyatomic ion on the left and I see it on the right, I can balance that just as a polyatomic ion if I want to, or I can take it apart and balance the phosphorus and the oxygen separate. Doesn't matter which one I choose to do. So I'll give you about 3 minutes. Well, let's say 2 minutes because it's almost 11. So at 10:57, then I'll give you the answer. All right, so in this case, just to save a little time, you want to balance the metal, which is strontium, first. Well, strontium and lithium, those are both metals. Then you want to do the non-metals, then you want to do the polyatomic ion last. All right, I'll show you how I do that one. You're gonna look, yeah, that happens sometimes. Oops, are no fun. Been there, done that. Okay. Strontium, lithium, phosphate, and chlorine. I balance phosphate as phosphate instead of phosphorus and oxygen just because I see it on both sides. Oh, Caspian's done. All right. So here's the answer. And this is the order that I balanced in. I put 3 here. That was the first one. And then the second one is lithium. So I balanced the metals in this one first. And then I kind of in my handwriting in my own notes, I believe I put 6 here, I think. I think that's what I did. 3, 2, and 6. All right. So let's count them up. Make sure I got it right. So on the left, we have 3 strontium, 6 chlorine, because it's 3 times the 2. And then 2 lithium. Well, oh, you know, I left. This is why you're going to loop cast, and I forgot the coefficient. I mean, subscript. Sorry about that. Okay, so we have 6 lithium on the left, and then you have phosphate. Okay, so on the right, I have 3 strontium, 2 phosphate, 6 lithium, and 6 chlorine. So that's 6. All right. Yeah, it was the script. That was my fault. I wrote for you guys to work on. I forgot to put 3 there. So, yeah. Met that up, you guys. So, yeah, Chad, 6 p.m. because I forgot to put the coefficient when I copied for the problem from my notes. I forgot to put the 3 there. And it really made this one extra challenging. So I didn't do that on purpose, doesn't it? Sorry for that. So start working on your homework tonight. Don't stress if you get to see and you can't figure out the cost of the fact that we moved the exam up a little bit. I'm changing the homework date to next Tuesday. Yep, Tuesday. The second one will probably be moved as I'll have to count. Just all right. I'll see you guys on a Wednesday.